Alright, welcome back to the part 2 of our tutorial 2 for vectors. Part 1 we have finished until question 8, so now we are going into question number 9. Okay, let's look at the question 9. Given that vector A and B are given as such, find the angle between vector A and B. Okay, our question 9 here. Given vector A is 2 minus 3, 4. And vector B is minus 6, 1 minus 3. Alright, so find the angle between vector A and B. The only way to do it is using the dot product. Okay, we start with dot product first. A dot B. Since we are only given components, so we multiply the components first. Yeah? So we have this, then we have plus minus 3 multiplied by 1 plus 4 multiplied by negative 3. Okay, so we have minus 12 minus 3 and then minus 12 again, so we have minus 24 minus 27. Okay, so that is our first formula. Okay, and then we have a second formula for the dot product as well, which is the magnitude of A multiplied by the magnitude of B and cosine theta. The theta is the angle between these two vectors A and B. So we already have this value, minus 27. And then the magnitude of A is the square root of all the components. Okay, you have 2 square plus minus 3 square plus 4 square. Okay, that one is the component, the magnitude for A. Now magnitude for B is the same, minus 6 square plus 1 square plus minus 3 square. Okay, and then we multiply by cosine theta. Yeah. Okay, so we simplify the number first here, minus 27, and this one. Okay, so we have 4 plus 9 plus 16. This one is 4, right? Okay, plus 16. So we square root. Okay. So we have a square root 29, and then multiply by this square root. This one is 36 plus 1 plus 9. So we have, with square root 46. Okay, square root 46, and then cosine theta. Right. So our cosine theta is equal to minus 27 divided by square root 29 and square root 46. Okay, let's find out what is the value here. 27 divided by cube root 29. Sorry, square root. Okay, and then we need to divide again by another one, 46. Alright, so have 0.7392. Okay, so after that, okay, we find the arc cosine of the answer. So the angle is 42.3 degrees. Okay, so that's the answer. The angle is 42.3 degrees. Alright, next one. Our next one is question 10. So our question 10, given the vector, determine the magnitude direction of A plus B. Okay, we write down the vector for A first. Our vector A is given to be 5 plus 3j, and vector B is 3i minus 7j. Okay, so first we need to find A plus B. Okay, A plus B, the same component, sum up. this one sum up, you got 8, and then this one become minus 4j. Okay, so determine the magnitude and direction. Okay, our A plus B, the vector become 4i minus. Okay, so that is the summation of two vectors. So now we have to use a diagram to help us solve the problem a little bit. So 8i is in this direction. Okay, so this one is the 8i, and then minus 4 down here. Okay, minus 4 down here, so this is minus 4j. So then if we combine these two, okay, we're going to get this vector here. Okay, this is A plus B. Okay, and the angle that you need to calculate also is the alpha. Okay, alpha. Yeah. All right. So now the magnitude of A plus B is the square root of 8 square plus minus 4 square. Okay, so we have 64 plus 16. Okay, and then we find the square root, which is 8.94 units. Okay, 8.94 unit, and then the angle we can use tangent alpha. Tangent alpha here is minus 4 divided by 8. Okay, so our alpha is, okay, so up tangent, this one is minus 4 divided by 8, right? You have minus 26.6, minus 26.6 degree. Okay, so that one is our question 10. Okay, next 11. Question 11. Find the resultant vector for the vector shown in figure 2 below. Figure 2. Where's figure 2? This. Okay. Find the resultant vector. So only find resultant vector. Okay, let's look at that diagram. It's a bit small here. East, north. Okay, so we use east, north. We have east and west, and then this is our north and the south. So this one is the north. Okay, so we just use our geography method. North is good enough, so the rest is east, west, and south here. So we have three vector. That one is displacement. So I will start from here, this quadrant at 70 degree or 20 degree from the east is 28 kilometer. Okay, 28 kilometer. So this one here, I will use purple color. 28 kilometer at 20 degree. Okay, so I'll call this one S1. Okay, S1, 28 kilometer. Okay, and this one is 20 degree. And then you follow anti-clockwise, we have another one 45 degree, 18 kilometer. So 18 kilometer, this one is 45 degree roughly. 18 kilometer will be much shorter. Yeah, this one. Okay, so this one I call S2. Okay, their displacement, yeah, and this one is 18 kilometer, and the angle here is 45 degree, and then followed by this one is 60 degree at 35 kilometer. 60 degree, okay, 60 degree at 35 kilometer, much longer this one here. Okay, so we have this S3, 35 kilometer with an angle of 60 degree. All right, so we have all the information. So we need to find resultant vector. Okay, so to solve this problem, we have to find the component for each of them. Okay, so the component, we actually use red color here. Each of them have their own respective horizontal and vertical component. Okay, can you see that? Okay, so their respective component is either cosine theta or sine theta. Yeah, so I will start by using S1. Okay, so this one here, okay, so it's going to be S1x, and this one here, okay, is going to be the S2x, and correspond to the S3, this one is S3x. Okay, and then after that you have this. Okay, so this one is S1y, and this one here is S2y, and this one here is S3y. Alright, okay, so now we can write down their value. S1x, okay, S1x is equal to S1 cosine theta 1, and then we have this S1y is equal to S1 sine theta 1. Okay, we put in a value. This one is 28 cosine 20, and this one is 28 sine 20. Okay, and then followed by the second one, we have F2x and S2y. This one will be S2 cosine theta 2, S2 sine theta 2. So our S2 is 18. Both are the same, 18, and then this one is cosine, the angle is 45, and this one is sine 45. In this case, both will be the same answer. And then followed by your S3x and S3y. This one will be S3 cosine theta 3, S3 sine theta 3. S3 is 35, and cosine angle is 60. This one is sine 60. Yeah? Okay, so now we use calculator to solve the problem. 28 cosine 20, so we have 26.3, and then 28 sine 20, we have 9.58. Next one, 18 cosine 45, this one is 12.7, this one also the same, 12.7, and then have 35 cosine 60, right? So we have 17.5, and then 35 sine 60. See, answer is 30.3. Okay, 30.3. Alright, so after that we sum up everything. Okay, sum up everything, I with a I, J with a J. Yeah? But before that, be very careful which one positive, which one negative. Alright, so for the first one, S1x is positive, and then the S1y, this one is negative because pointing down. Yeah, pointing down, so we have negative sign here. And then after that, 2x is negative. Okay, 2x negative, 2y positive, and then for the 3x, 3y, both negative. Okay, both negative. Yeah? Okay, so now our resultant value. Okay, resultant is the I with the I. So this one is I, 26.3 I minus 12.7 I, and also minus 17.5 I. Okay, and then minus 9.58 J plus 12.7j, and finally we minus this one 30, okay, minus 30.3j. Okay, so our final answer will be 26.3 minus 12.7 and minus 17.5. So this one gives us minus 3.90i and minus 9.58 plus 12.7 and then minus 30.3. So we have minus 27.18 or 0.2, sorry. (27.2j). Alright, so that is our resultant vector. Okay, resultant vector. Okay. Alright, so that is our patch. This is number 1 for part 2. Okay, so there is our question 11. Okay, next look at question 12. So question 12.